Hi Year 13s, in this video we're going to talk about decomposition. And to do decomposition we are using this graph here, or our recomposition graph. Now this one looks slightly different. This is from Insight, and Insight compared to NZ Graph, it produces a decomposition and a recomposition graph, but in NZ Grapher, we just have the one graph. So this one looks a little bit different because we don't have the fitted model or the trend plus seasonal line on here. But yeah, we can still do this process from the graph even with the fitted model on here. Now, with decomposition, if we think about decompose, or the word decompose, to decompose, we can kind of think about it as breaking apart. If something decomposes, it breaks apart. And so what we're doing, if we're looking at this graph here, it's broken apart. We've got the seasonal effect here. We've also got the residual panel, and we're looking at trend. We're looking at each of these things and how much they account for the variation that we see. And so we have this table that we use to help us. So we have some different rows: raw data, trend, seasonality, and residuals, and the columns min, max, range, and percentage of contribution. And so firstly, we want to find out, well, what's the overall range in the data? How much variation is there within the data? And so if we find the highest point where the data reaches and the lowest point where the data reaches, this is our minimum and maximum. So the total change in the data is about 8,000 building permits. That's the total variation we see from the highest to the lowest point. And this total here is going to be used to help work out the percentage of contribution that each of the other things has. And our next row is for trend. And so if we look at trend, these blue lines have been put on here, and it might be helpful to put these kind of lines on to help you line things up against the scale, but you don't need to. But it can be useful to help estimate. And so you want to be careful in your estimations. You want to try and be as accurate as you can. And so our lowest point where our trend line reaches is there, and so that's at about 9,000. The highest point is here, which is about 15,300. And so the range there, by subtracting 15,300, take away 9,000, we get a range of 6,300. And so if we do a calculation, the range for trend divided by the range for the raw data, we get the percentage of contribution of the trend. Essentially, the trend accounts for approximately 79% of the variation within the data. Most of the change we see here is due to the fact that the trend line has changed quite a bit, and so you can see our trend line's gone down quite a bit. Then we have seasonality, and so we're looking at the seasonal swing section here, and so our lowest point is about negative 1,000 there. The highest point is about 600, and so that's a range of about 1,600. So always highest take away the lowest. And so if we do a calculation there, dividing that number by the total range, or the range of the raw data, we get about 20%. So about 20% of the variation, or the change we see, is related to that seasonal pattern or that seasonal swing. Now lastly, we have residuals, and so here we don't do the minimum and the maximum. We try and find the largest residual, and so looking to see where it kind of spikes the highest or spikes the lowest. So in this case, we're about 1,000 below, so that's the biggest change here. And so there's about 13% contribution to the residuals. And so we've got the example on the website to use to help you. My video time's about to end here, so hopefully that makes sense, and you've got some examples to help you talk about it.